Hey everyone, welcome to this week's coding live stream. Thanks for joining me this afternoon. I'm glad you're joining me. I know that it's summer and sometimes we like to take a break during the summer, but whether you're watching this now live with me or you're watching it later, I appreciate you wanting to learn more about coding, and I think that only helps you in just about everything else that you do. But today we are going to use custom blocks in Scratch. And so Scratch has this feature that allows us to create blocks that we can use over and over again whenever we want to use them. Scratch isn't, I wish it was a little bit better about allowing these custom blocks to be used for all of your sprites in your project, because I think that's where the real power in custom blocks comes in. And in other programming languages, these may be called functions or methods. You might see them called that in other programming languages, but Scratch doesn't allow us to do that. So we're going to take with what we got and talk a little bit about how we use those today. So I'm in Scratch. I'm going to create a new project. So when we start out with our Scratch project, many of you are familiar with this, but these are all of the blocks that our character understands. Our sprite understands right out of the from the beginning. So we have all of these blocks and we can tell our characters to do whatever we want them to do. And those things happen when our character sees those. But say we have something that we know is going to happen over and over again on our game. And we know this, and we know that we want our character to be able to jump or some other feature that isn't necessarily already one of these blocks in Scratch, but a combination of these blocks to make our character do something. And so that's where the custom blocks comes into play and where they're useful within the programming environment. So the way we get to those is go to My Blocks and Make a Block. So I'm going to start this out just with a regular block without any of the inputs, and then we might modify it and see if we can add some of those inputs a little bit later on, just to show you the difference between how we would use those different inputs. So I'm going to name this block Jump. That's up in this area here, and click OK. Okay, so once we've done that, I'm going to zoom in here so you can see that. Two things happen. One, a block was created over in the left with all of the other blocks so that our character understands. So our character now has in its mind, I know what, I know that if I get the jump command, I know that there's something that I should do about that. Well, what happens is when this character, our Scratch cat, comes across the jump block that you've given it, a jump command, behind the scenes, we are trying to find a definition of what jump means. So that's the way these functions and custom blocks work. We have that where we actually use the function by calling this jump block, and then we have the definition for this function that we have to stack some blocks under so that our character understands what's going on whenever we use the word jump. So as of right now, nothing is happening, but we do have this link. So if we were to click jump, notice that this define turns yellow because it's saying, hey, I'm using jump. Oh, here's the definition for that. Let's run this code here. There's nothing there, but we're gonna go over and try to do that anyway. So that's what happens. Okay, so let's add some things to make this this definition for jump. So what does a jump really look like on a screen like this with the Scratch cat? A jump is actually making our character go up and then come back down. So let's start to add those things in place there. Whenever we're changing directions up and down, we use the change Y, because remember, up and down is the Y direction, left and right is the X direction whenever we're talking about coordinates in the system. So I'm going to change Y by 10. Now, if I just run that, it makes my character go up like this. But what are we missing here? What part of the jump are we missing? The coming back down part. So we could simply add another change y by 10. Change this to -10. These always need to be the same number. Otherwise, our jumps are going to look, they're going to stair step as we move along across through here. But if we click jump now, what's happening? Why doesn't it look like my character is jumping? They actually are moving. They're just moving so fast. We're going up by 10 and down by 10 so fast that it look like we're in the same spot. So we're going to add something from the control blocks here. Control weight in between change y by 10 and change y by -10. Let's see if I can zoom in a little bit more. Okay, now if we click on this jump block, assuming that I can see it, now we are changing y by 10, waiting 1 second, and then changing y by -10. And really, that 1 second is too long. So we can take it less than 1 second, and we use decimals to do that. So we would do something like 0.3 for that. And it looks like they're just continuing to go up. I'm not sure why we're continuing to just go up and not come back down, even though we have a -10 here. That's interesting. There it is. Maybe I was just clicking it too fast. Sometimes if we're clicking it and it's waiting from the initial jump, it will automatically start the next. So if I click jump several times, this wait isn't happening before I click again, and so it's continuing to jump up the screen. No problem there. I'm going to change the wait a little bit shorter and then change the jump a little bit higher, just so we get some more effect in this. Change y by -20 and 20, and the wait is 0.1 second. So now we have something that looks more like a jump for our character on the screen. All right. So as of right now, this jump is only going to jump the same amount every time. Whenever we see this jump block in our code blocks, we will do this definition here. And that's really where it's useful for functions. If there's something that's outside of the typical flow of our code. So when I talk about flows, we're doing these things in order. I don't want a big bunch of blocks in the middle clogging it up by saying, do all of this stuff. I want to be able to move that away and just create my own block. So maybe let's go to event, when flag is clicked. So when flag is clicked, I'm going to jump. Or when space key is pressed, that's usually a better one for this. I'll just change that and get rid of when flag is. So when space key is pressed, my character is going to jump like that. Okay, so now we're going to edit this, and we're actually going to use some input blocks to make this a lot more flexible for our code. So maybe we have in our code we have power-ups, or we have something else in our game that allows the person to jump higher at certain points, or maybe there's certain surfaces that they're standing on, maybe a trampoline type surface that would cause them to jump higher at certain times, but their normal jump is just this 20. So we're going to edit our jump command. So we right click on the definition and click edit, and I'm going to add an input that's number or text, and I'm going to call it height. Click OK. Okay, so notice a couple things changed for our code blocks this time. Where we use the jump actually has an open spot now, so we can type something in here. And in our definition, the height variable that we just added, the input that we just added for this custom block, is over here in the jump. And so what we want to do is we want to tell when the space key is pressed, we want our character to jump 20. But maybe let's go over to event. When the up arrow is pressed, I'm going to go back to my blocks and I want to jump 40. And let's make it a lot higher just so that you can see the difference. All right, so as we're going along here, when up arrow key is pressed, jump 60. When space key is pressed, jump 20. But right now, it's going to jump 20 every time. Do we see why in this particular case? Is there anything that you see about this definition that would make it do that? So the definition that we have set up right now only has this number 20 in place and minus 20. But if we take that 20 and replace it by height, and actually we want to replace this by, let's use some math, multiplication, height times -1 to make it a negative number. All right, we want this height, the second change y, to go down in the y direction. So it has to be a negative number. But this number, as we're bringing it in, is positive. So we have to make sure that we multiply it by -1 to get that value. All right, so now we have when space key is pressed, jump 20. This number 20 is passed over into this definition as the variable height and then gets substituted here in the change y and the second change y. Same thing happens down here, except 60 gets passed in. So you can try that. You can use the spacebar key and then try the up arrow. Give our character a much higher. You can change these numbers however you see fit. And like I said, maybe you have a power up that lasts a certain amount of time on your character, and you could control that. Let's see how something like that would work. I'm going to add another sprite. Let's add an apple. And quickly on my sprite, I'm going to make my sprite move. So motion, yeah, let's make event. When left arrow key is pressed, motion, move 10 steps, but I got to point the direction first. Point in direction to the left. Event, when right arrow key is pressed. I'm just going to move to the right and to the left because I'm using the up arrow for something else right now, so I don't want to. And then I'm going to duplicate these blocks, drag them over, and just change the direction. And we notice my cap flipped. The way to stop that cap from flipping is to click on this direction block just above the sprites, and down across the bottom of this circle you have here, that's showing the direction. There's these two arrows that are pointing to each other. Choose that one, and then that will let you move back and forth. So maybe what we want to happen is whenever our cat grabs this apple, now they're going to be able to jump like super high for, let's say, 5 seconds. So let's program that into our game to make that functionality work. What we want to do is for the apple, when flag is clicked in the events, down in control, we're going to bring a forever loop. Actually, yeah, let's do the forever loop. And then a wait until inside of that. So this is a forever loop, which I've cautioned you against using. That's going to happen over and over. But we have a wait until that's actually stopping the loop each time. So it's not continuously running in the background. So wait until sensing, touching, change that to sprite 1. And when it's touching sprite 1, I'm going to looks and hide, which means I have to show it at the very beginning, because otherwise when we restart the game, it won't work. So we're just going to make it hide for right now, and then we're going to make it so that it will. So we grab the apple, stop, flag. Now it showed back up. That's what we want. So once we grab the apple, we're going to broadcast a message from the apple to our sprite. All of the jump commands are over on our cat sprite. And so we want to make sure that all of the code handling for that happens over there. But we need to know from the apple that, hey, the cat has touched me, I've disappeared. Now it's time to start your power-up phase. So I'm going to go to events, broadcast message. I'm going to change to a new message. I'm going to call this one power up. Broadcast this message power up before I hide. Over on the cat, events when I receive power up. When I receive power up, let's think about how I want to do this, because there's multiple ways you can do this, and your code may be different from mine. That's perfectly fine. But what I want to do is maybe give us just a double the amount of jump if we're in power up mode. So when I receive power up, I'm going to create a variable, make a variable. It's called in power up. And if it's 0, then I'm going to do nothing. But when I receive this power up command from my apple, I'm going to set in power up to 1. Events or control, wait 5 seconds. Go back to variables, and I'm going to set in power up back to 0. Okay, so the apple is touched by the sprite. It broadcasts this message that says power up. When the cat receives that, it's going to set the variable in power up to 1, just for those few, and then wait 5 seconds and then set it back to 0. So let's see what happens and how we can change this definition to actually listen to the power up. We're going to use this in power up variable. So I'm going to say control. We're going to do an if then or an else. Let's keep it all together and clean. There's multiple ways you can do this. I'm going to put a giant if then else in there. If operators, and bring this one that has equal over. So if in power up equals 1, then I'm going to add some code for that. But if it doesn't equal 1, which means it equals 0, then I'm going to do the normal stuff in this else statement below. So I'm going to duplicate all of this just because it's handy to be able to do that. So we see what's going on here in this giant if else. Whenever we jump, if the power up mode is 1, then we're going to do something different here. And if the power up mode is 0, which is what happens in this else, then it's going to do the normal. So really all I need is this operators and this multiplication again. And I'm going to go 2 times height. And for negative, I'm going to go -2 times height. Okay, so if we're in the power up, then use these 3 blocks of code. Else use the normal blocks of code, which are not multiplied by 2. All right, so let's see if that works for us. I'm going to click the flag at the top. I'm going to go get it, and I'm going to leave the variable showing at the top, the in power up 1, just to test and see that it's actually in power up mode. Ideally, in your own game, you would be playing some music, or I know in Super Mario, when you get the star and you're in power up mode, it plays a special music in the background. Something like that would be nice to have in your game. So I'm going to go grab it and power up to 1. Now my jump. Notice I started going back lower right after that. I'm going to try that again just so that we can see. Actually, I'm standing right on the apple. So I'm going to go over I'm going to start clicking the up arrow, which means that I should be using this that says jump 60. 60 is passed into this definition. Power up is at 1, so I'm actually jumping up 2 times 60, which is 120. And then I'm coming back down, minus 2 times 60, which is negative 120. So watch what happens here. I'm going to go grab it, jump up high. You can watch my character. I'm going to continue to do this, and then they're going to start not jumping as high because the power up mode is over. Okay? And we can use these functions to, and this is actually where it's kind of handy now that we don't, every time we jump, we don't have all of this code in this, and in this, we have it all set up just in this definition for our jump custom block. And that way, whenever we use it, it's a lot cleaner. It's a lot easier to debug later on. And, if someone else is looking at your code trying to figure out what happened, we know that all of the functionality around the jump is right here. Just like variables, though, we want to name these something that makes sense to us, the programmers, and anyone else any other programmer that may look at our code later on. Technically, the Scratch does not care, and no computer programming language ever cares what you name your functions. We could call this Flilly Flappy or something like that, and it would do the same stuff that we defined on here. Whatever we define is what's going to happen. But we name it something that's useful, that's memorable, and that we can understand as humans, so that when we come and look at it later on, it's easier for us to solve. All right, does that make sense? If you have any questions about this or have your own custom blocks that you've made that you'd like me to check out, please feel free to share those with us. We'd like to hear more about some of the things that you're working on. Or if you, like I said, if you have questions about this, you can comment on this video in YouTube or in Facebook, in our Facebook video. And we'll be sure to get to those as quickly as we can and try to answer those questions for you. Just a heads up, next week we're going to use Scratch again in this live coding session. So we're going to be using Scratch again. And then the following week, I will be out of town doing some hiking, but we've already recorded a video that we're going to use for that. It's an introduction to Roblox Studio. So for the whole month of July, we're going to use Roblox Studio. And my son is going to be joining in because he's been creating things in Roblox Studio a lot more frequently than I have. He's much more familiar with the environment. And I think he'll be a good resource as we start to work through Roblox Studio on how to do that. But again, that'll be, I think July 1st is the Thursday for that we're going to save a video on Intro to Roblox Studio so that you guys can check that out as well. Make sure to like and subscribe to our Facebook page, or click that notification tab inside of YouTube to make sure that you get notified whenever we go live. All right. Thanks for joining in. If you're watching this later on, thanks for watching, and hope this was helpful for you. Bye.